Sure. So, a very good afternoon to everyone, and welcome to the second proposition of this semester and of this online series 4. Today, we have Dr. Purva Mujumdar, who is going to speak on a topic which is information management in architecture, engineering, construction operations industry with BIM. And before I hand it over to Dr. Purva, I will quickly give a brief introduction about her. She holds a PhD in construction management from IIT Delhi, and she is a civil engineer by training with a master's in structural engineering from Illinois Institute of Technology, Chicago, USA. Currently, she is working as an assistant professor at School of Art and Architecture, Sushant University. And before joining academics, she had worked as a structural engineer with many reputed organizations of building and highway infrastructure. She has authored book chapters in Smart Innovation, Systems and Technologies book series, and Advances in Structural Engineering in Mechanics Volume 1. As a doctoral research fellow, she has worked on a funded research project and has more than 15 publications and a software prototype tool to her credit. She has keen interest in design management, planning and scheduling in construction, automation and computational techniques in construction, digital transformation of architecture, engineering, construction, building information modeling, and design construction interface. So without further delay, I would now request Purva to share her work with all of us. Over to you.
Thank you so much, Sobia. So I'll just share my screen.
Yeah.
Is my screen visible?
Yes.
Okay. Hello, everyone. So I would like to share my ongoing research work with you all on what I am working on. So before I start, I want to give a quick introduction on my previous research work. So I basically did my master's in structures, but then I moved over to construction management for my PhD. When I moved over to construction, I focused more on the design phase of any construction project. So when I talk about design phase, it's more about management of information. What is an information exactly? And how information planning, scheduling, and management, its management is very critical to project success in achieving a complete success of a project. So when I did my doctoral research in information management for design phase, I primarily focused on structural design phase. But now I have moved forward. I've taken it forward for the future aspects of managing information across all the sectors of all the phases of our construction project, construction industry sector, which includes our architectural, which includes engineering phase, which includes construction and also operations. So how do we talk about information, managing the voluminous information across all these phases, and how do we use it? How do we achieve it with an upcoming technique known as building information modeling? So I'll come over it later. I'll first start with information, the basic of information. So if I focus just on architectural engineering phase itself, when the design is ongoing, a lot of information exchange happen, and that is how the entire process of design evolves. So when a project is comes into being, when a project is tendered, we always think about what is the statement of need, what is the purpose of the project, and then it goes across various design stages, which is having conceptual design stage, where we develop the entire concept of the project. Then we go forward with schematic design stage, where the schemes and a little bit more detail is explored. And then we go with the detailed design stage, which is about preparation of the design documents as well as the construction drawings. And then once that phase is done, the outcome, the deliverables of those phases are basically your specification for construction and good for construction drawing. So that is how the entire design process evolves. Now, what influences design actually across all these processes? So design is a very elaborative phase, and a lot of decisions are taken right from the finalization, thinking over the ideas and concepts, finalizing those concepts, and then putting it on paper. So a lot of information exchanges happen among all the stakeholders involved, among all the participants involved in the project, and that happen in a form of like 3 C's, which includes collaboration, coordination, and communication. And these 3's are very critical to smooth and proper exchange of information. So I'll just explain that with an example. For example, if we have a beam, which is this is a beam where refrigeration conduits were planned and the dimensions were to be finalized. So an architect who is involved in the project, he or she suggests some dimensions for it. Then the drawing goes to, then the design goes to the steel fabricator, and then he mentions his own changes into it. Then it travels over to a lot of people, including engineer. It again comes back to architect. Then it goes to HVAC person, engineer, then other. So a single finalization of a dimension goes over to many people involved in the project, and all these changes and modifications that they propose, it happens actually in sequence, and it happens rather manually. It happens repetitively. So when these type of things are finalized, we have a lot of design information that is being exchanged between the people involved. Now, this is the traditional idea of a design process. Right now, focused only on the architectural and the structural design process. So we start with a lot of, we start with first the design intent. Why do we want to make this structure? Then we start with the architectural plans, then layout, structural plans and analysis. Then the design of structural members happen. Then the design drawings are prepared. Design verification is done, fabrication is done, and then the handing over after inspection and approval happens. So as you can see, this is like a cyclic and repetitive process, and a lot of information flow is happening across all these stages among a lot of people involved. Now, why do we need to plan architecture engineering phase? We need to plan it because the maximum exchanges of information flow that is to and fro, that is happening in the design phase, in the architectural engineering phase only. So as you can see, there are a lot of modes of information communication that happen between people involved. There are repetitive information that travels through. The design changes proposed by the client and the other people, they come through. There are a lot of external inputs from designer. There are reviews happening. There are program design and construction program reconciling happening. Deliverables sharing among design discipline is also involved. There is a lot of interdisciplinary involvement in any project, and all those people who are interdisciplinary, they come up with their own ideas of the entire design. And this is the observation that I've taken from a lot of different projects. That includes highway project, building project, as well as intercept receiver and offshore facilities. So any kind of construction project it is, we always deal with a lot of information during our architectural and engineering phase. Now, all the stakeholders and team members that are involved in the project, they have their own viewpoint. For example, an architect's viewpoint is totally different than a structural engineer's viewpoint. Similarly, an MEP engineer's viewpoint about the same project is different than HVAC. So when we have people come forward with a lot of different varied viewpoints, then it's very difficult to get a holistic view of the entire project together. And especially when they have varied viewpoints, they have multiple information flow happening among them. And this information is not an independent type of information. It's like a lot of dependencies also there in the information. For example, a structure person always needs input from architecture or a geotechnical engineer or a plumbing or HVAC engineer. And similarly, the other people also. So information that is exchanged can be independent, which doesn't need input from each other. It can be dependent where one piece of information is important, is required to execute another activity. Similarly, they can be semi-independent where they can overlap for this information flow, and they can be interdependent where the output of one activity serves as an input for another. Similarly, the output of the second activity is actually an input for the first activity. So we have, and in addition to that, we have a lot of entities which are involved in a project. So this is a specific project that I've taken, highway project. I've just chosen like 3 teams: structural team, highway team, and hydrology team. And we have a lot of components that are designed across. We have a lot of activities in it which are executed. And then we have a lot of parameters. Parameter is basically the most primitive type of information that flows across all these varied disciplines. With all this multiple information flow that is happening across these multiple entities, the project, executing the design of the project is a very haphazard and is a very cumbersome type of process. And the overlaps for information is not a new thing. Overlap happens among information where it can be like no overlap for information. It can be a natural overlap. As I said, that output of one activity can serve as an input for another one. And then there is a forced overlap because we need to compress the design phase because of schedule issues also. So we sometimes go forward with missing information or with half information, incomplete information, and then when the information is finalized, we again come back. So there is a lot of rework happening. There's a lot of repetition happening in any architectural engineering design phase because of this information flow. Now, these are a few factors which are influencing our multiple information exchanges. There is some mental flow of information that is going in just a single designer's mind. Then there are like a lot of information rework happening. It can be a positive type of rework where you are actually improving on the values. It can be a negative type of rework also, which generally happens with human error or calculation error or other deadline pressures in a project. It can be communication factor also that can influence all these type of multiple information flow, where we have like a lot of coordination is not there, lack of coordination is there, overhandling of information by just one person involved in it may also be an issue. Then we have a lot of information that is happening, that is exchanging in a single design team across different designers, and then varied design team across different varied designers. So all these type of information is, as you can see, this figure is all jumbled. So you can see that a lot of information exchanges happen because of involvement of a lot of team members are there, and they're working across different activities and working across different deliverables. That is why we always have information exchanges happening in any architectural engineering phase. Now, this is, I have taken just a single case study of a highway case project, and you can see in these oval shaped, you can see the design teams involved, all the teams involved in the project, and look at the information and exchanges that is happening across all these teams. And it is the purpose of making this figure jumbled or a little hazy is I wanted to draw attention of everyone to this aspect, that information flow doesn't happen in a planned manner. Information exchange is always haphazard and never planned or scheduled across any type of project. So with this type of working primarily in architectural engineering phase, we tend to lose a lot of information across all these projects phases. So when we start planning, the amount of information that we are dealing with in the beginning is very less. But as we go forward in different stages of the project, the amount of information that is being exchanged and handled it increases. And a lot of information loss happens. We tend to miss out on some information and don't keep track of some information, especially during the design phase and the construction phase. So our design and construction phase is basically our main architectural engineering construction phase. And Lot of information loss is happening. As you can see, when we go forward with this information, we cannot keep track of the changes and modifications and reworks and repetitions that are happening across these stages in our operation and maintenance phase. So because of this type of, so my motivation for this research is basically we have to execute a lot of multiple entities are involved, and information is being handled by multiple people across these multiple stages and at multiple levels and sub levels. So it is kind of perplexing because we are interacting among each other very frequently, we are overlapping for information, and we are collaborating in different capacities with other entities for information. So holistic, a complete planning and view of multiple information flows in any project. The changes that are happening across all these stages, the modifications that we are taking forward by all the project stakeholders for an entire project is required. We have a lot of discrete disciplines involved in varied stages, and their independent views complicate execution of project. For example, if I am a structural engineer, I have a different view of looking at a project, and that if I introduce any kind of change and modification, it may clash with other designers' models such as our HVAC model or our MEP model or our architectural model, or even a construction manager's model, which is more stressing over the cost and schedule aspect of a project, which we don't consider in design phase. So information exchanges, as I say, are unavoidable. They are complex. They are very cumbersome to plan. And if we don't manage them properly during the design, the architectural engineering design phase, what will happen is it will eventually affect the design schedule and the design cost. So all these types of information exchanges need to be managed. We need a proper system for managing all the information in the project across these multiple disciplines and entities and throughout the project life cycle. So now this is our current architectural engineering construction model. So as you can see, we are working in bubbles, we are working in silos. There is a design engineer organization where primarily architects or other engineers are involved. And in that bubble, they don't really involve owners, they don't really outside people, they don't involve our operation and maintenance people whose role come only after the project is handed over. Similarly, the schedulers and estimators, they are not involved together. So as you see, this is the conceptual diagram. This is representing that we work in boundaries. We really follow our boundaries strictly, and we work in a fragmented manner. So even if the information exchange is happening across all these teams, it is happening mainly through our emails, mainly through our design documents and drawings, and it is happening sequentially. If I'm initiating a change, it is traveling from my end to another person's end, because we are sitting in geographically different locations. The other team which are involved in the project, they don't really have an idea on what changes we are introducing. So the information handling, the information exchange is basically traveling across different teams in terms of mails, in terms of drawings, in terms of file transfer protocol or fax or other things like that. So this is the end result. When we execute a project, we have a lot of delays, which is very potential to happen. We have unexpected contingency cost as well. And we are using a lot of paper and shipping and drawings, which is not very environment friendly. So for a typical project data, if I pick up, if a company, if we involve all the people who work on a single project, I just put an estimate that if there are 420 people involved, including all suppliers and contractors and vendors and retailers, we have the individual participants working as 850, and they all generate different types of documents to communicate their information exchange. And then we tend to print a lot of documents. We tend to hold those documents in our office, and it's really like creating, we are even electronic data that we are creating is almost like 3000 MB to hold this much volume of information. So we need, number one thing, to identify that information management is crucial, and we need to seriously and very critically plan, schedule it throughout our design process, throughout our project stages, and we need to automate the process. So We know that our project execution is a kind of inefficient process. The industry is fragmented because we look to each other, we look at each other as our adversaries and not as a team member working together on a one single project. We have manual processes which are very ineffective and outdated processes. We are very much resistant to technology. Construction sector, the construction projects are still going forward with no technology, manual methods of working. We need a collaborative, we need a coordinated and well communicated process, of course, that allows all the participants involved, including architects, engineers, contractors, even manufacturers, and all other professionals which are involved in the project to plan, design, and construct a structure. We have to simulate a 3D model in which all the stakeholders involved in the project can be on the same page and look through all the changes and information flow that happen across the project stages. Now, even for that, in addition, we need effective management of operations phase also. So operation phase generally starts when we hand over the project to the client, when the project is handed over after construction. And that is the time, that is the stage when the operation and maintenance comes in. And we never really plan when we plan a project that how that stage is going to be executed. So the advantage of automating and digitizing our whole construction industry is when we plan out all these phases right beforehand we start the project. So we need an integrated design, construction, operation process through all the phases of project life cycle, which is very critical for project success. Now, when we talk about digital transformation, as you can see with this slide, that all the industries presently are very much digitized. We are now in a new normal after the pandemic, and all the industries that were operating manually are now digitized. Our travel industry, when we had to book a ticket or when we had to plan a vacation, we always went to travel agents. We went for car rentals and taxis. Now we have booking.com, Expedia, we have Uber, we have many different services for our perusal because everything is being digitized. If we want to talk about retail sector, we used to go to supermarket, we used to go to fashion market, we used to go to very different industries to pick up for the retail purpose. Now we have eBay, we have Amazon, we have all these sites, we have all this digitization that is happening much before the digitization in construction is proposed. If we talk about media, we used to look forward to music and cinema and encyclopedia for information. Now we have Google, we have Wikipedia. So it's a very big example that everything, every industry on this planet now is completely digitized or in the process of digitally transforming. So why not our construction sector? So if we talk about digitizing construction sector, the best and the upcoming technique that is coming right now is our building information modeling, which stands as BIM. Now, what is BIM? BIM is basically a complete information model, which is, it's like building a complete information database in a 3D model, and it can take you through all the stages of the project, all the participants, all the activities, and you can add various aspects such as schedule, such as cost and sustainability in a project, which were not possible earlier when we were working with manual methods. So this picture shows that when we start with, when a project is started, the conceptual design starts, then we go with detailed design, then we go with analysis, documentation, fabrication. So all these stages, the model is evolving, the entire building model is evolving across all these stages to various perspectives of people. So if I'm a structural engineer, I can look through this model and I can get the idea of what changes are being initiated from my side and how it is affecting the other people model. So now we are no more working to and fro, we are working together in the project. We are in this project together. When I talk about we, it includes all the stakeholders involved and not just the architect or designers. It includes your suppliers, it includes your fabricators, it includes your manufacturers, and it includes your owner and your operation stage people as well. Then the fabrication, and then after we build this 3D model, we are now exploring more dimensions also. For example, 4D, where the fourth dimension is the cost, or fourth dimension is the schedule. So how, when we plan this model, how this model will come up, how the project will be executed across this schedule which we are proposing, what activities will be happening on day 1 and what we will be doing on day 300. Similarly, fifth dimension talks about the cost, that if I initiate a change right now, if I want to use some other system like services, if I am housing a mechanical system in my structure right now, and if I want to use another mechanical system, so when I introduce that mechanical system, what cost changes are going to happen in the project. So now we are no more talking in terms of just the plan, elevation and views. We are now presenting the scenarios, the project scenarios, that if we have this scenario, how the schedule and cost will come up, how the sustainability aspect will happen, how the entire project execution will happen. Similarly, if I present second scenario, how the changes come up. So it is like virtually seeing the project going in front of your eyes before it actually starts to come into being in reality. That is what BIM is doing. So again, I would like to reiterate, BIM is not a software. BIM is both software and a process. BIM is an execution process of a project. It helps you with a sound execution of a project. So this is how a BIM pyramid looks like and what this building and information management stands for. Now this building doesn't stand for a structure. It stands for the geometry. It stands for everything: architecture, structure, HVAC, MEP, whatever disciplines are there in the project and whatever information is involved. When we talk about information, it's not only the design parameters or any kind of information change. It also includes like what codes we'll be using, what scheduling data will be needed, what manufacturer inputs are there. So wherever the team members are coming forward and giving their input on something, that comes as an information. And then the management, when we talk about management, we need to know that this is how we deal with the entire process. Entire process means how do you execute the project, what is the completion status, what is the approval status, and how do you execute the quality control, how do you finally hand it over to operation and maintenance. So that is what this BIM pyramid stands for. So our project delivery is now no more across stages that we did, that first we do the design stage and then we do the detailing stage and then we do the construction and then we do execution and all these stages. Now it's like an integrated project delivery. So start to finish, you can employ BIM for your complete project execution and across the entire project life cycle. So we have the collaboration for information that was happening in a very haphazard manner. It can now be more organized and structured, and it is more coordinated now with a 3D model. So we started from 2D paper drawings and 2D two-dimensional documents for exchanging our information, and now we can switch over to the 3D model, and this whole model stands as an information flow model. So these are the processes which BIM offers you. So BIM level 0, when the BIM came up, we started with CAD, that is computer aided design. We always dealt in 1990s, we always dealt with drawings. Basically, we dealt with two-dimensional drawings and documents. And we mostly exchange the information through paper. Now, in 2000, we started advancing. So 2D became 3D. So now in three-dimensional, we have an entire model which serves as an information for everyone involved in the project. And collaboration started in terms of file-based collaboration and no more paper-based exchange. Went to BIM level 2 in 2010, then the BIM came over. So 3D, our BIM model, where we are no more dealing only with the files, we are dealing with entire information library. So it's like building a database, building a library of all this information flow. And when we want to go forward with level 3, future of our industry, we are talking about the data is integrated now. And in my BIM model, it is visible and it is interoperable, changeable to another person's view, another designer's view based on his own requirements. So we are now in this, we are aiming towards this phase, we are aiming towards this type of evolution in our construction project sector. So this is how a BIM environment looks like. We have an entire BIM environment in which we have a platform. A BIM provides you a platform with a lot of softwares, with a lot of processes involved, and then it gives you a lot of tools to use. So for example, if I talk about Revit structure and Revit architectural are two different tools, but they come under the same BIM server, BIM platform, which is our Autodesk. So similarly, one service is providing you all types of different tools to use, and all those information model can be integrated together to see the holistic view of a complete project. Now this is the different type of information exchange method that is happening. External level, if we see on external level, we have multiple user. As you see, they are having different views of the project. When we talk about conceptual level, they tend to connect with each other for information, and then they try to see the other person's view in the project. Now, when we talk about database management system, we need to bring the interoperability among all these different users involved, and that is where we are aiming towards to go. So we have now realized that the file-based information was a very manual and outdated process in our-based information. It's like we have to build a cloud of information in which the database of information can. Okay. Oh, is it clear?
Yeah, better.
Is it clear now?
Yes.
Okay. So this is where to go.
You can try switching off your camera. Your voice is cracking again.
Okay. Is it better now?
Yeah.
Okay. So we have this. We have now realized that the file based or the manual methods of managing information and exchanging information cannot work in today's time, especially because our projects have become innovative, our projects have become complex. We need a complete database management system for a project, and that is why we need something. We need these upcoming techniques where we can store all this information, which is ready to use and ready to see for everyone. So why should we care about BIM? Because if we think of the entire phase, so design and construction phase, the architectural engineering and construction phase actually go for 1 year, from 1 year to 5 years only. But the operation and maintenance phase, which is the concluding phase, concluding stage of the project, goes 20 plus years. Any project that goes into operation stages and maintenance stages, that is way beyond than our design and construction phase. So we need a system where all these people can see through the changes that we planned, the decisions that we had taken during our design and construction phase, and it influences a very bigger phase. So the loss of value because of value of the slope of line is basically indicating that we have made a lot of effort to maintain, to manage this information and to produce this information. And this basically goes very high in construction phase, because design and construction phase is the phase where a lot of information collaboration happen. And hence, we need to care about another type of working where we are more in sync with each other, we are more coordinated as team members, and we are on the same pedestal when we think about a project. So this is the building life cycle model, and you can see that the feasibility and the design stages in any project is basically a very small part, almost like 10% part. And then when it goes from build to operation and maintenance, renewal or refurbish, and then decommissioning, that stage is a lot bigger time period it has, and we need to bring this part into it. So I have proposed, I mean, I've been thinking over and working over this idea of that whenever we talked about our construction projects, we always discuss how AEC is involved, architectural engineering construction matters. We never thought of using that O, which stands for operation. So now our projects are no more only AEC, they are AECO, which includes architectural engineering construction and operations together. That will give us the entire complete holistic view of any project, because all these stages is critical for project success. So now we can see the scope that in if we see about pre-design stage, the effort needed to maintain the information is very less, but it keeps on going. It shoots up really very high when you when our project progresses. So if we use an automated type of information management system, it gives us an edge over other projects, and we really need the management of information becomes quite easy to handle, easier to manage. So this is my way forward. I mean, right now I'm in a very beginning stage of exploring BIM for information management across AECO projects. So I am now looking forward with how the information management can happen for the entire project throughout the life cycle of the project. I am working towards developing a collaborative knowledge integrated system and automated system for architectural engineering, construction, operation, and facility management. And how do we handle and manage the real-time project information when we integrate the entire project life cycle and BIM together? And then how we can adopt and implement BIM in our industry as well as in our course curriculum, because these people, when they study, they will go in industry and they will be our future professionals in eco industry. So how the BIM, the education of BIM helps them take over this digitization of construction projects. So I am basically a member of India BIM Association also, and I am also steering the digital transformation of construction sector along with many people. And this is where I end. Thank you so much.
Thank you so much, Purva. Your work, your presentation was quite informative, and it was great to hear from an engineer's perspective about BIM, about all of this. So, do we have, if we have any questions for Purva, anybody can put it on the chat box or can directly ask her here. Or you can raise your hands also. We'll wait for the questions, but as I was listening to your presentation, Purva, I mean, you've concluded it that way, where you were putting your way forward. But I also felt that in pedagogy, in education also, there should be some overlaps. Hello, if I'm audible?
Yeah, I think the network was a little weak. Yeah.
Yeah,
I
so
can hear
even
you.
I was thinking about the same while you were presenting your work, that in education, what the problem that we all face is that we all work in niches, at least at the educational stage. But when we enter into industry, then is where we see the overlaps in the project. So in education, if there could be some possibilities where an interaction between the architects, engineers, or other professionals could happen to understand the integrities of these projects, where we're using technology, we're using digital mediums, or we're using BIM, because we all have our own entry points. And information exchange, as you were saying, it's complex and there is no planning as such. But what if we find that a way where we can
Yeah,
identify a system?
actually, when we think about a project, we really think about what is our role in the project, and not we don't see it holistically. And our part, any team person, any participant involved in the project, that person's part is really very less. If you see the entire project, how it is executed, so we really work on our parts, and we finish someone and what is in, how it impacts all these stages. So as I said now, I worked in highway sector, and the highway sector design phase itself prolonged till 2 to 3 years till the project goes into construction. And during those years was no system.
Purva, your voice is again cracking. I don't know if it is at my end or the issue is at your end. If you can switch off your video, that might work. Are others able to hear Purva properly?
Oh, no, ma'am. Her voice is breaking.
Purva, if you can switch off your camera. Hello? I think we are facing some network issue. We'll wait
Picked
for
up.
her to join. Yeah, Purva.
Yeah, so all the industries and sectors across this planet now are, in the process of digital transformation. Some have already transformed, some are in the process. And even the product industry that we see, it is, if we have to design a car, you can see how much digital transformation has already happened in that industry. So why should we lag behind? Because it's a very big sector. The construction sector is a very big sector, a huge sector, and a lot of people are involved. Why can't we also, adopt the same type of mindset that we want to create less waste, we want to have sustainable structures, we want to simulate everything that is coming on in reality. If we if we can see through the structure that is coming in reality in like initial design stages itself, then our work is less or structured, more organized, and we save on cost and schedule, which is a very major factor for any project success. Cost and schedule if anything doesn't happen in an organized and a planned manner.
Right.
Yes.
I have another kind of a question only. Like we are looking at BIM as something which is a way to come up with cost effectiveness, more sustainable kind of a project. But there have been, I mean, projects in earlier times, like traditionally also. So are we saying that traditionally the projects used to be non-sustainable just because the technology was not that advanced? Or can we still learn something from our past traditional knowledge of how they used to execute projects? Because time is one factor which BIM can address. Cost, yes, but again, the project itself takes 3 to 4 years if, for example, to to complete, to come into the final stage. So that time factor is also something that might create some kind of an hindrance in what we are, in terms of data we are putting now. And then keeping time as a factor, what changes in terms of cost also happens. Like after 3 years, the cost that we have calculated now might change. So is there a possibility where we are looking at all those factors, time factor, cost factor in BIM,
That is what
and
I was
can we
saying
learn
about
something from our past knowledge, something which we are not discarding just because at that time the technologies were not that advanced or we were following some other systems of project management?
I'm never saying, or BIM never claims that you get your old knowledge not discarded. Knowledge is now more integrated and coordinated by a mean. So it is more for executing a project and automating all those manual and repetitive tasks that we were doing. Because when we think through not just a 2D drawing, when we see through a 3D model, we can add various. For example, if I initiate a change, this is what happened with me when I was in industry 15 years, 16 years back. We used to go to architect for a meeting, and in the meeting when some change is initiated or some change is discussed, we again went back to our drawings and did that change. Now when we change something, the mechanical person or the HVAC person drawings also got affected. He said that this is clashing with my system, my mechanical system. Again we have to take his idea into consideration, and again we are looking through these changes. So a lot of design changes and modification that we suggest, that we plan through, they keep on traveling across all these participants in manually, and that's how the project gets delayed. Information exchange is actually a very critical parameter, a critical reason factor which is influencing our design schedule. We have a set design schedule that the design should be completed in this much time, but we are never achieving it. So this is what happened. Now when I'm working in a 3D model or a BIM model, and all these stakeholders are connected together through that model, if I initiate a change in structures, automatically the change is highlighted in mechanical person's model. So again, he can come up that this is clashing. So we see through a lot of errors and omissions. We see through a lot of clash. We can detect the clashes that are happening with other people, which we were doing manually. And then when we do these things, we can add the cost aspect also. The fourth dimension talks about the schedule, and the fifth dimension talks about the cost. And then we are now thinking about 6D and 7D, which is sustainability. Now, when we have seen through a project completely in a 3D view, virtually we are simulating a project in a model form. We are seeing through how it will execute across this schedule and this cost. Now, if I choose to have some sustainability measure also, for example, if I see this is my wall, I am introducing a window over here. This is the scenario, sustainability scenario. Now, if I remove this window from here and put it somewhere else, how the sustainability scenario changes. So as I said, we are no more talking in terms of plans and elevations. We are talking in terms of different project scenarios. And those scenarios not only include the changes or modification in design, they also include the cost aspect and schedule aspect and the sustainability aspect as well. This is what virtual reality is doing.
Right. Thanks, Purva. I think Neena ma'am, she have raised her hand. Yes,
Yeah,
yes, Neena ma'am.
yeah. So thank you so much, Purva, as very informative. So I'm just going to address Sobia's last question, where she was talking about how in our traditional architecture were we unsustainable, that we now need BIM to become sustainable. So one sort of method of looking at this could be that traditional architectures did not deal with the issue of scale. So everything was, very scalable. Everything was very accessible. So therefore, sustainability was integrated into the design process. It was passive design, so as to speak. Almost nothing which was designed based on our traditional knowledge systems or even vernacular architecture is not sustainable. It's green, it utilizes nature very, very effectively, but as a passive design process. But because now the world has gone through this huge information overload, and also because the scaling of architecture has now become unfeasible at a kind of personal or community level, I mean, you're sitting in India and you're designing for a building in China. So therefore, what automation and computation becomes extremely critical. And without this, and we've been through phases where we have scaled up architectures without the use of technology, it's very tedious. Technology has instantly made all of these, global projects possible. It has allowed us to look at sustainability as integral. I mean, we now no longer design without it. It's part of our design process, and I think that's where BIM becomes a very important aspect. Right, Purva? Does that make sense?
Yes, ma'am, of course. So
Yeah.
my idea, I see some more questions. Can I go forward and answer them, Sobia? The chat
I was
box.
about to, I was about to read it. If you allow me, I'll read it to
Yeah,
you.
okay, sure.
And thanks, Neena ma'am, for, answering. That answers my question. Preetham sir has written a nice presentation, ma'am. How do we really introduce fundamentals of BIM in bits and pieces in our education system so that graduates don't learn it just as a software to get employed? And another question to that is BIM still hasn't reached the kind of acceptability as compared to its potential. 90% architects and consultants do use CAD. What is the basic issue as per you?
Yeah, so for
How
the
would you
first one,
address?
first one, I still think that it should be included in our course curriculum. I'm also offering an elective on for School of Art and Architecture students for which is using BIM for project management. So we have this notion, even people who are studying and people who go into industry, they have this notion that it is only a software, but it is not. It is for the end. It's an entire process. It's basically a platform on which you execute a lot of things. As I said, now we talk in terms of dimensions and no more in terms of project. So when we pick up these dimensions, we see through all these stages and all the requirements of people involved. And when I talk about people, they're not just team members. We talk about their requirements in terms of deliverables, in terms of how the information evolved across all these stages, and how it basically how the physically the model will come up. So BIM provides an entire simulation. When I talk about the simulation, virtual simulation, it is not only in terms of the model, it also includes a lot of different aspects of the project which we never see when we do the design. So yes, it has to be embedded in education curriculum. We have to take through our so when now when I'm presenting this when I'm teaching this elective course, I am taking my students across this entire process, not just as a software. I actually am teaching them that how BIM can benefit architect, what information BIM has for architect, what information, what it can do for an engineer, what it can do for a supplier or a fabricator, or even an owner. An owner also has a completely different view of a project, which is different. Owner's view is basically guided by the cost and the schedule. So how we can include his view in also in it. Even the facility person, facility management, operation and maintenance person. So yes, these all different views should be taught, should be included in our curriculum. And because we need to address it over here in our education, otherwise when they go to industry, I know that acceptability of BIM is still very less. We are in the process of digitization, and construction sector unfortunately is the last. We are very much resistant to technology. We don't want to progress in those terms. So obviously it will take time, maybe 20 to 30 years. That is the vision with BIM. Where do we stand in 2050? And as I said, the digitization has started happening in all sectors. It will eventually come in construction sector also. We cannot avoid it. We have to adopt it somewhere down the line. I really don't know how much time it will take, but we need to take it forward with that mindset. I hope I answered. I don't know whether I answered it like what he wanted to know.
Yeah.
Thank you so much.
Yeah, I think you did. So I don't think there are any more questions or any comment. So I think we are good to close for today. And thank you so much, Purva, for coming and sharing your ongoing research. That was quite informative for all of us. And So this is it. We'll meet after 2 weeks again with another proposition. So, thank you so much.
Thank you, Sophia. Thank you so much.
Thanks, Sophia, very much for arranging everything.
Good night.
Thank you.
Thank you.
We can close the recording.